Okay, so then we looked at factorizing monic quadratics. So a monic quadratic is in the form of this, right? So ax squared plus bx plus c. That's always what we're looking at when we're looking at quadratics. Now, a monic just means that I don't have a multiple there. It's non-monic if I do have a multiple there. And it also means that if I've got more than x squared there, then it's not monic either. Okay, so that's what we're looking for when we're looking at quadratics that are monic. So we kind of looked at both, but you will be focusing more on monic quadratic expressions. And we looked at ones which had 4 terms. So if you've got 4 terms, then you're basically factorizing using grouping. So what we're going to use here is we're going to use the grouping method. And that just means that I split my terms up into pairs. So that's pair 1 and that's pair 2, including the signs. And then what I'm going to do is I'm going to find the highest common factor within each pair. So the highest common factor of the first pair there is x, and I take that out. And I've got x minus 2. And I'm going to take out minus from this one because, again, I'm looking for something that is similar to this. So I have a binomial factor. Then I'm going to take out minus 8, and I've got x minus 2. Let's just check, make sure I've done that correctly. So minus 2 times minus 8 is positive 16. That's what we want, so we're okay. Right, so now I'm going to go, well, what's the binomial here? The binomial is, of course, this one, right? So those are my important things there, and that then gets brought to the front of the equation. And then I'm going to have x minus 2. And what goes in my other bracket? What's left? So what's left here is x and minus 8. And that goes in my second bracket. So I've got x minus 8. And they are called my highest common factors. What about when I have a trinomial that has 3 terms in it? So there are 2 things I can look at. I can either look at it and try and factorize it using the cross method, and the cross method is most useful when I don't have a monic. It's more useful when I've got a multiple in front of my x squared, and so that of course just means that I look for the factors. So this is the cross method, and you look for the factors of AC that add to b when we refer back to how a quadratic is set out. Remember, ax squared plus bx plus c. But the main thing when we're looking at this one is that when I then have my cross method, I put the factors of x over here. So there could be some sort of multiple. I've got maybe ax here and bx, whatever a and b are, right, that multiply to give me my my variable in front of that, right? And I also have to look at the factors of c. So this could be, you know, e and f, whatever those 2 multiply, and they will give me c. And these 2 will give me the a in front of my ax squared. So really, we should call this d, right? So that just will allow me to then figure out what factors add then to my middle term. So if I multiply these through, I should get my middle term when I add them, combine them together. And it will also tell me what goes in each bracket. So whatever's in this will give me my first bracket, and whatever's in this will give me my second bracket. Okay, so this example is clearly not a monic because I have a multiple in front of my x squared. But I'd still use the same method. The only difference is when I have a monic, I won't have any of these multiples in front of the x, and it makes it a lot easier to find my factors. So I would actually only be looking at factors of c that add to b, and then I would just put any numbers that multiply to give c there, and then I work out whether they multiply through to give me my middle value. So that's how you would, most of the time you're going to use the cross method. But the most important use for the cross method is when I actually have a multiple in front of my x squared. So if we look at that and I go, well, I'm always going to be looking at it crossed like that, I need to find the factors of 12 and the factors of negative 2. And then I'm going to trial them in my little cross there. So the factors of 12, well, I could have 3 and 4, 1 and 12, or 2 and 6. Okay, the factors of minus 2 are -1 and 2, or -2 and 1. And the whole thing about the cross method is that it's trial and error. So if I go, well, I'm going to trial the first batch, I'm going to trial this one from this one and that batch there, and then I'll see if they work, and if they don't work, I'll cross them out and then try different numbers. But remember, you're going to have to trial this with both of these, and then this one with both of these, and then this one with both of these, just to see that if it works. Because it's all about combination when we're looking cross method. So if I then put it in, I've got my x values always go on the left hand side. So x there, x there. What's the multiples in front of my x? I'm going to try 3 and 4. And on the other side, I'm trialing -1 and 2. So I've got 2 times 3, which is 6, and -1 times 4. So do I get -5? So I've got -4 plus 6. Does it equal my middle value? I've got plus 2x, right? I'm looking for it to go from there to there. Now, is that what I'm looking for? No, I want -5. So I know that that is the incorrect combination. So what I'm going to do is I'm just going to flip either the values on the left-hand side or the right-hand side and trial that. Since I've got a nice little interactive screen here, I'm just going to... Oh, no, I'm not going to... Okay, so I know it didn't work before, so now I've got to try it with a different set. So I'm still using the same one, so I'm going to use 3x over here and 4x over here. I'm just going to flip the ones, these two values over. So what if I had, before I had -1, what if I have 2 here and then minus that? So then I'll have 2 times 4, which is -8. No, sorry, +8. Minus 3, which gives me, remember their x's because I multiplied them through, which gives me 5x, and I want -5x, so I know that doesn't work. So I could now safely say that that one is not the correct one. But now I'm going to trial the same multiples of my x and try them with -2 and 1. So again, it's lots of trial and error, which is why you don't really want to do it unless you're looking for something like this. So where it's a multiple in front of the x squared. So I've got 3x, 4x. I'm going to put -2 here, and I'm going to put 1 there, and let's see if it works. So I've got 3 times 1 is 3x, -2 times 4 is -8x, which gives me -5x. Wow, look, it's the same. I forgot to write my x up here. It's the same. Okay? Great, we know what we found. So therefore, whatever's on the top now makes up my first bracket, and whatever's on the bottom makes up my second bracket. And I'm just going to put it together over here. So I've got 3x minus 2 and 4x plus 1. And it's solved. Okay, so it is all about trial and error. If that didn't work, then we would have to cross out my values for 12, and I'd just have to keep trying. It's very laborious, but it is very helpful when you have to do these kind of problems by hand. Splitting the middle term. So splitting the middle term is basically the step before we can do the grouping method. So we just want to make our 3 terms into 4 terms, and that just means that when I have something in the form of ax squared plus bx plus c, I'm looking for the factors of ax, so my numbers that will multiply to give me that value, that add to b. And then I split b using those terms. Okay, so, and then I can proceed using the grouping method. So let's do an example. Before we can proceed, I need to look at this little equation and say, well, is there a highest common factor? Because you know it's going to be a lot easier if I take out the highest common factor first. So, is there something which goes into all 3 terms here? Yes, there is. It's 3. Let's take it out. So I've got 3 m squared plus 6m plus 8. Okay? So now I know that I don't have to deal with anything really. I can basically ignore that 3. Basically just pretend it's not there. until the end and just put it back in, but just keep writing it and then continue what's in the bracket. So I know that I've got looking for the factors of, well, that coefficient in front of the m squared is just 1. So I'm looking for the factors of 8 that add to 6. So what are the factors of 8? The factors of 8 are 2 and 4, 1 and 8. So 2 and 4. If I add 2 plus 4, let's see. 2 plus 4 equals 6. That's what I'm looking for. I want them to add to this number here. So they add to 6. Therefore, I'm going to split the middle term using 2 and 4. So I've got 3, right? M squared plus 2m, don't forget the m, plus 4m plus 8. And now I just proceed as if it was a grouping problem. So I've got the 3 again, and I'm looking for highest common factor between m and 2m is m. I've got m plus 2. 4m and 8 is 2m, 2, sorry. So I've got, 4. So I've got m plus 2. Do I have a binomial factor? Yes, I do. That goes at the front. And then my highest common factors here, which are, of course, m and plus 4, they just go in the second bracket. Sorry. Yeah. Oh, sorry, there, I've put them in the first bracket. So I just put my binomial in the second bracket. Okay? Doesn't matter which order you do it in as long as the combination's there. So if I've got m plus 4 as my highest common factors, they can either go in the first bracket or the second bracket. And my binomial factor, whatever it may be, just goes in the other bracket. So I can either have this bracket first or this bracket first. It's not going to make any difference to my expansion. If I had to expand this, so that I want to get it back to this one here, I expand the brackets first and then multiply through by 3. And as you know, that is the best way to check your work. Unless you have a calculator, then you can just do that. Okay, so that's it for factorising quadratics, monic quadratics. Exercise 2.3 questions if you want any extra work or chapter review or practice tests.